So we're going to do the next part here, and we're going to start with set notation. Okay, so what is set notation? Set notation is a way of writing your answers for solutions. So set notation has a couple of features. First of all, we have these sort of curly brackets, we can call them if you like, okay, in which we write our solutions. Now, don't be too intimidated by this. I'll show you kind of what the minimum is in just a moment, but we do need these brackets here, and you will start to see some other notation that will become more familiar through the course. This one, you'll see this one later. It means like is in the domain. It means it belongs to. So what we're saying here is you can write them like 2x plus 1, right? If x, it belongs to this one here, this means an integer, okay, like a whole number. So don't be too intimidated by this symbol coming up, and so a lot of the time it doesn't really change anything for you. But we're going to talk about using the brackets in just a moment. So all real numbers greater than 5. Well, this is the kind of thing that you see a little bit more, okay? So we might need to write something like this. So again, it's inside the brackets, and the way I like to think about this is it's written this way. The rule about x, yeah? The rule about x is, and then here's the bit that you would normally do. X is bigger than 5. So the rule about x is bigger than 5, and that's it. Yeah, and then you kind of close off your brackets. How about this one here? Just have a quick think about this one before I reveal it. So the rule about x, again, presumably, is that x has to be less than 5. Now, this is the union symbol. The union symbol, I would say, is a bit like or, okay? So it means you can follow this rule, or you can follow this rule. You don't have to do them both, okay? Like, we're looking at numbers less than 5. We're also looking at numbers bigger than 7. That's kind of how I like to think of this, okay? If you are asked for set notation, again, we need the brackets, we need correct inequalities about the correct letter, and we do need the symbols of union and intersection. So I'll show you, well, there we go, intersections here underneath. So this one is sort of an inclusive inequality. So the way this is written, okay, this is totally fine. But if you wanted to use some of these other symbols, this would be an example of when we could use the intersection symbol. The way this reads is the rule about x is x has to be less than or equal to 5, and it also has to be that x is less than or equal to 7. Okay, so this here, this is a stricter requirement. You've got to follow both of these rules at the same time. The union is a bit like, you know, you can do this one or you can do this one. Okay, so this is a little bit looser. So sort of based on my experience of marking this is a good little test for you, okay? So imagine I said, I'd like you to solve this inequality, or I'd like you to make sure that x is at most the number minus 5. What would the solutions to these two conditions look like? How would you write them? What would the set notation be? So something like this would do it. This isn't the only answer, but this is an answer, okay? At most means the number, so that's why it's got the equals part, the number, and then less than the number, okay? At most 5 means you can have minus 6 as well, right? That's kind of the idea. This one here, where do these come from? This is from solving this, right? So like factorizing it and getting minus 2 and minus 3 you should get. In fact, let's just test that out. So you get x plus 2, x plus 3. Yeah, okay. So it also said it's the bit, oh no, I think I'm going to change this. I accidentally made a mistake on that one, okay? I'd like you to think of it being the other way around. So if I wanted to do this bit here, including the two of them, yeah, this is what it would look like. All right, and that's what I'm going to go with because this is the example I've written. So you've got the brackets, you've got the union symbol as well. All right, so set notation, this is what we need. Please don't overthink it anymore. Notice I've dropped the x dot x is less than minus 5. Okay, this is great if you can write this, but what's on the board there is a minimum. That's okay. So we're going to just super quickly, and I really do mean super quickly, go through inequalities. So inequalities, you do the normal rules, don't you? Okay. These ones here are written in set notation, notice. Combining inequalities, people are terrible at this, okay? And it's so easy. So I encourage you just to make a quick note of how this one's done. I really like this method of doing this. It says, think of being less than 3 and think about following this condition. Well, the and is a little bit like the intersection symbol. It means we're only looking for numbers that do both of the things. So number line is a great way of representing it. So this is, you're not allowed 3, and it's the number smaller. This includes 2, but doesn't include 4. So if we follow both of these, if we're looking for the bits that follow both, in general, we're looking for this sort of middle part, okay? So what you're going to see here is 2 and 3, okay? 2 and 3, where 2 can be included, and it has to be less than 3. And I can show you that this is right, because just take a number, 2.5, and just test it out for yourself, okay? It works. But you don't want to be there all day doing this. So this really is the way to do this. And it does come up as part of A-level questions. So this is a really good one to check that you know how to do. Use the number line, easiest way ever. Solving quadratics then. Solving quadratics, I've just talked to you about this quite a bit. So a little reminder here, get a 0 on one side, factorize, sketch, and reason, okay? So this is the same as this. It means exactly the same thing. When it's greater than 0, what does it really mean? Well, if you like, it's kind of saying to you, like, where is the y bit, if you like? Where is the height of the graph? Where is it less than 0? That's what you're really saying. So where is the height less than 0? Well, it's not here because it's not on the graph, so that's not a valid answer. It's not here because it's above 0. So we must be talking about these points here. So this is what we're actually trying to find. And then it's just convention that the way that we answer that is in terms of x, okay? So we're talking about, I've answered that the wrong way around again, haven't I? Sorry, I said greater than 0. So greater than 0 is these bits, okay? But then it's our convention that when we answer it, we can't just say, oh yeah, it's these bits. We answer it in terms of the x values, or the critical values. So you should be saying it's to the left of -5 and it's to the right of 3. And this is the set notation way of doing that. Okay? So another one, what's this? I think the inequality sign has just changed. So this one is in fact what I was just talking about. Notice it's between the same values. It includes the -5 and the 3. If you don't have the same inequality mark, you will drop the marks on that one there. Okay, and we're looking for the in-between region. If you do the sketch, you know, x squared, positive x squared, smiley face sort of shape, something like that, it really is quite trivial, okay, if you do that. And again, check it with the calculator, please, okay? We do not need to drop any marks at all on inequalities, especially if they're numerical. So this one here, what could we do? Well, we could do x squared plus 5x plus 4 is greater than or equal to 0. Follow the same steps. Over here, x squared is less than 9. Well, x squared is, let's do x squared minus 9 is less than 0. We could try factorizing these first. You know, 4 and 1, that's going to work, isn't it? Okay, 3 and -3, you get the idea with this, okay? Even if, and I would say it's probably more common for it not to be 1x, 2x, for example, is the same idea. I've taken this from a paper. So the critical values, yeah, but look where the marks actually come from. The marks actually come from picking the right region, writing the correct inequality. So it's not enough to just say, oh, that's 3.5. Oh, that's -1. No. We're not interested in that, okay? We're interested in 2x squared, x squared. We're interested in the general shape. We're interested in the fact that it's less than 0, so it should be an in-between region. This one here, I'm going to actually kind of skip this one now, okay? Because this is really now more in further pure, so I don't think we need that one anymore. A couple of quick questions there on the board. please have a quick go. I'm going to reveal these for you in just a moment. Pause the video now. Okay, so I haven't done these with set notation, although we could. So we get our critical values, picking the right region. So this should be, if it's a smiley face and it's above, it's looking away, which is why they're disconnected. Less than for a smiley face means it's an in-between. This one here. Interesting thing you can do on this one, right, is if you solve it, you'll get x plus 3 is less than or equal to, well, yeah, I mean, it's not the nicest one actually in the world. No, let's scrap that idea. Okay, I probably would just expand that one. Yeah, I probably would just expand that one. I was going to talk about solving with completing the square, but you can perhaps see here, solving with completing the square is going to get a little bit confusing with the inequality. So expanding it out, moving the 16 to the left-hand side is probably the way to go for that one. This one here, this would be a good test of your AC method. Remember the AC method? The AC method is when you say, I'm thinking of factors of AC. So AC in this case means the A value, the coefficient of x squared, 3 times C, which is minus 6 AC. And you try and think of factors of minus 18 that sum to the middle number. So what on earth am I talking about? Well, if you play around with this, minus 18 and 1 is not what you're looking for, because that gives you minus 17. We're looking for minus 7. So the way to do that would be a minus 9 and a 2, right? We then rewrite it. So we rewrite 3x squared. I'm going to write minus 9x. However, I could write 2x. Either way will work. So I'm writing it in such a way that I'm breaking up that 7x, yeah, based on what I see here. So this is just kind of a nice trick, the AC method, this is called. Then I put minus 6 is greater than 0. The way that it then works is you split this into two parts, and you factorize the left, you factorize the right. You factorize as much as possible. So 3x goes into both of these, yeah? 3x would leave you with x. 3x times x is x squared. 3x times what over here? This is x plus 3. Is it x plus 3? No. It's x minus 3. Over here, if you factorize, you should find something quite unusual happens. So factorize the most you can, which is a 2. And it leaves you with x minus 3. Do you notice how they both have x minus 3 on them? This is a good sign. We then say that x minus 3 appears on the left 3x times. X minus 3 appears on the right plus 2 times. Okay, so this is called the AC method. Hopefully you are familiar with it. If not, you really do need to practice this. You need to be fluent with this, okay? Or inspection is also fine. But that's a nice way that we could get those values. And then when we get those values, we know that this is a positive quadratic, okay? We know that it's greater than 0, so we see the pattern already, okay? To the left, to the right. That's why the word or is there. We've covered quite a lot of ground there. We've covered linear and quadratic inequalities. So as I said, make sure your AC method is really good. Use the calculator to verify your solutions, please.